Okay, here we go. So what we want to do is we want to graphically state what happens with Newton's method. And I need you to understand from yesterday exactly where this happened. So you were able to do the iteration as we speak, where you simply do the formula over and over and over again. You plug it in your calculator, correct? Let's understand the nature of Newton's method and where it kind of actually originates, and that's in the graphical approach. You're trying to understand what the heck Newton was doing. He says, I have a function, and it crosses somewhere here on the x-axis. We want to find that exact location. And so what we're going to do is we are going to make a guess. By making that guess, we determine the point on the curve way up there, and we then draw a line tangent. What part of that tangent line do we then find? The x-intercept. That becomes our new guess. So if this was x sub 0, this would then be x sub 1. We then plug it into the function to find the point on the curve. We draw a tangent line. What do we then find? The x-intercept. That becomes x sub 2. We then look for the point on the curve and the tangent line. That becomes our new guess, x sub 3. You see how it can go right to that spot very quickly. Does the graphical representation convince you at least a little bit that it does a really good job? Yeah, and so you can understand the ingenious of Newton in that approach. And yet it's pretty simple. I mean, all we did is we just said x minus f of x divided by f prime of x. I mean, that's all it was. Do it over and over again, you're going to come up with a solution super quick, an approximation, an estimation. Well, it does actually matter where you make a first guess. Yesterday, it really didn't. You guessed anywhere, and you came up with the right answer. Today, we're going to show you why it truly matters. And what you have to do is you have to think about that geometrical representation, that graphical piece. So let's give it a shot. Determine graphically what happens if Newton's method is used for the function whose graph is shown below, given the initial guess. Watch what happens. You must follow the procedure. I guess 0. If I guess 0, I then find a point, and I draw a line tangent. First of all, there are only 2 points where this graph crosses the x-axis. What are those 2 spots where it crosses? It crosses at 2 and 6. Do we all agree there? It only crosses at 2 and 6. So this x-intercept here, did that bring me closer to 2 or further away? It brought me further away. Well, maybe it'll bring me back close in the long run. Let's try again. So let's plug this point in here and see what happens. Shoot. It's still bringing me further away, isn't it? Yeah, exactly. You plug it in again, and you can see that the x values are just going further and further and further away over and over again. So in this situation, if you were to guess 0, it would bring you all the way out, time over time, it would bring you out to negative infinity. It's up to you. It kind of gets to be a large mess after a while, so I'm going to try to clean it up here a little bit. All right, let's now guess 1. Watch what happens when I guess 1. If I guess 1, I find that coordinate. I then draw a line tangent. Uh-oh. Where does that cross the x-axis? It doesn't. You'll never find an x-intercept, will you? So if you pick a spot where the derivative is 0, it's going to be undefined. Please look at the equation so you can understand and put the pieces together. The equation was x minus f of x divided by f prime of x. We said if you plug in 1, the derivative is 0, correct? Look at your formula. If the derivative was 0, do you understand why you get an undefined result? See how that matches graphically with what's going on? Yeah, exactly. What if I guess 3? Let's see what's going to happen if I guess 3. I guess 3. I find this location right here. I draw a tangent line. Did that bring me closer to 2? Yeah, it does. And I understand that you may say, well, I need to be careful on how I draw it. I get that. That sometimes if you don't draw the tangent line very well, then it may lead you away. But, hopefully you can convince yourself the intention of this one is to show you that what happens is if you guess at 3, you're going to find the solution of 2. That's going to be the end result of Newton's method. That is going to be the end result of Newton's method. What if I guess 4? Undefined. Why? Because the spot that you guessed has a derivative of 0, and when you draw that tangent line never crosses the x-axis. So therefore, you will get an undefined result when you do Newton's method. So now I look at 5. I guess 5. Find my point, draw my tangent line. Did that bring me closer to 6 or further away from 6? Closer. It's on the other side of 6, though, isn't it? Well, so we're either going to go to 6 or maybe we go out to infinity, huh? Let's try again. I mean, it's not simply where you just do it once. You should do it over and over again. So now I take that point, and I find a point on the curve. Did that draw me back closer to 6? Yeah. Are you convinced now that it will draw you back to 6? Yeah. Sometimes it jumps back and forth a little bit at the initial spot, but, it definitely gets back there. So it gets us to 6. I don't know about you guys, but I just think that that is super cool to see what happens graphically and to see how that matches with the formula. What do you think? So we are putting ourselves in the position of Newton. It says, use Newton's method to find all roots of the following polynomial to 4 decimal places. So if you look at this, that would be like asking this question, x cubed minus 4x. We would like to find those solutions. And if you factor out an x, you get x squared minus 4, and then factor that, you get x times x minus 2 times x plus 2. 3 solutions, right? We'd like to know if this has 3 solutions or 2 solutions or 1 solution. But Newton has no ability to factor this because the cubic does not factor. Well, that's not entirely true, but it doesn't factor to a way that we know or understand at all, does it? So Newton wants to find all these solutions. That's what we're going to try to do. So we are going to use our calculator for help because we are cheaters. If you don't like that, then go ahead and do it by hand. You all agree that this shape looks something like that. So I'm going to propose to you that bad guesses would be right here and right here. You agree that those are bad guesses? Okay. We're all on the same page there. All right. Well, I would like to find those spots. How do I find those spots? I take the derivative, yeah. So I have y prime is equal to 3x squared minus 2. Set that equal to 0. 0 equals 3x squared minus 2. And I get 2 is equal to 3x squared, or 2/3 is equal to x squared. I root both sides. So I'm going to look for the square root of 2/3. Now, Newton could approximate that pretty quickly. It's going to be about 0.8, right? 0.666. We take it to the 1/2 power, take the square root of it. Sorry, I did it the long way. We get 0.81. Okay with that? So plus or minus 0.81. So it looks like this would happen at 0.81. This would happen at negative 0.81. So I don't want to guess at 0.81 or negative 0.81. Everybody agreed? So I'll try to find the one in the middle in case it crosses the x-axis. Remember, folks, we don't know if it goes like this or if it goes like this or if it goes like this. I mean, you know, we really don't know for sure exactly, do we? So let's keep our minds open to the possibilities that maybe it crosses the x-axis once, maybe it crosses 3 times. So I use Newton's formula, which is x minus f of x divided by f prime of x. I go to my calculator, and I'm going to plug that in. Again, if you are uncomfortable with that because you feel like we're cheating by using our calculator, go ahead and do it by hand. I used to get people angry at me for using the calculator at this point. I'm like, go ahead, do it by hand then. Like, well, you say we can't use a calculator. We want to be like Isaac Newton. Okay. Newsflash, you are not Isaac Newton. Nor am I. So I have x minus the cubic divided by what? What do I divide by? 3x squared minus 2. So I go to the table, and I type in the value of 0. You said that 0 would be a good guess. Now what do I type in? 0.25. 0.25862. 0.25865. Wow, look at that. Just 3 guesses, and we are extremely accurate, huh? So we know this. It crosses at 0.25865. That's fine. I'm not going to be that picky. So it looks like it did cross the x-axis somewhere between negative 0.81 and positive 0.81. So what would be another good guess? Is it possible it crosses back here? So what would be a guess back here? Sure, negative 1. We'll do your whole negative 10 thing. Who said negative 10? Is that Rowan? Who said negative 10? Grace. So we'll do negative 10, okay? But first we're going to do negative 1. Watch what happens. I'll try negative 1, and I get negative 2.5. I go negative 2.5. I get negative 1.896, negative 1.896. I get negative 1.609. 609. It's going to take a little while, huh? Ooh, looks like we're getting closer, huh? Ooh, I like that. Negative 1.526. Everybody okay with that? Grace is 100% correct. You can try negative 10. Negative 10. But watch what happens. It's fun to just kind of play around with it and see what happens. Look at Grace. We ended up with a guess eventually of negative 2.5, didn't we? So negative 10. If we type in negative 10, let's see what we do. Gets us to negative 6.7. Negative 6.7, and we get to negative 4.5. Negative 4.5. I mean, you know, so it's going to take a little while to get there, but you still get there, you know. Look, now you're at the negative 2, so it takes you like 3 more steps. No big deal, right? Just do it. Might not be the best idea. Okay. Well, it crosses twice. Is it possible it crosses 3 times? What would be another spot I could guess? Sure, let's try 1. Ooh, 1.5. This is fun. This is like better than video games. Like, who cares about Fortnite or Dead Red Redemption? Play some Red Dead last night, Braden? What a good boy. And then I played Red Dead. So I know that sometimes you've looked at the polynomials. You said, well, I really don't know if I cross the x-axis or not. But notice Newton's method gives us a surefire way to always find the zeros of the polynomial. And so what you have here again is you can mark out the 0.25. You can mark out the negative 1.526. You can mark out the 1.267. And you'd be able to sketch a pretty good graph. And we know we can find the local maxes, the local mins, and the inflection point. There's just more points that we can add to all that. So we know exactly where it does cross the x-axis now. Kind of neat, huh? Last thing, take out your calculator, press y equals, and go x cubed minus 2x plus 0.5. As D. Weiland said, we're going to graph it. I'm going to go zoom 6. And we're going to bring you back to exactly what we did yesterday. If you wanted to find a 0, what would you do? You go second, calculate 0, number 2. And remember, you would go left bound because you're trying to say, well, what should we guess between? And you said, well, we're going to guess between negative 1.7 and negative 0.85. We're going to guess between there. What was our guess? Our guess was negative 1. And what does it produce? It produces the negative 1.526 for us. How does your calculator actually produce that value? It does Newton's method. It's not like your calculator is some super brain. It does what we tell it to. Maybe the calculator has power over us and we don't know it, and it's actually controlling our society. Could be. Sounds like a good movie. Question, Grant. Your graph turned out that way. Press zoom 6. Okay, folks, you have your assignment. It's the second page on your notes. Or second page on your worksheet from yesterday. You're good to go. Yeah, so you have Newton's method plugged in right now. You just need the cubic.